this way if everybody could just say real time and we mean it? So that's 2 out of 5. Let's make it 5 out of 5.
Let's do it.
All right, awesome. Guys, have at it.
Excellent. So you're saying that you have a much better and lower cost for hardware. I'd like to understand how that happens with memory versus hard drives, and also what kind of issues do you have on reliability over time?
So in our clustered solution, you can put MemSQLs and MySQLs together. So the cold data can live on disk. If disk is really the new tape, you treat that as essentially an archival mechanism, and then your hot data lives in memory with MemSQL. Eventually, hardware trends are on the side of more memory being cheaper, and we are durable by default. So you back us with disk or SSD, we actually write back, so it's persistent. So I don't know if that answers your question.
A little bit. I'd be interested in understanding more about the analysis that you've done of cost, and that's beyond the scope of this panel.
Yeah, sure.
But yeah, that's a main concern though, and also on longer life. So you obviously can migrate to and from disk, but over an extended period of time, have you looked at operational cost versus what they have today?
So in terms of the migration, it's very facile. I mean, everyone in this room can use us right now. We're MySQL compatible on the wire. So even though we're closed source, our inputs and outputs are open source. So actually going and migrating to and from disk, you're going to want to use basic tools. But if you want to keep the data alive and highly available, you split it across 2 data centers, best practice.
Okay.
How does your performance compare to Oracle's in-memory database?
2.5 times faster. And that's a apples to apples comparison. Comparing us to a disk-based solution is really apples to oranges. So the differential between that database in particular and us is that we do code generation, and we basically don't have to burn as many instructions to execute queries. When you give us a query, we actually detect, has it been compiled into C++? And if it has, we just point right to that shared object and repopulate the parameters. So there's a huge delta. I mean, if you run MySQL in memory, we're 10 times faster than that.
Okay, and so if someone has an existing application, database that's running, what are you looking for in terms of scenarios that would motivate you to approach that customer and convince them to try to migrate that into an in-memory framework? And how would they do that, or is this mostly greenfield situations you're looking at?
There's a lot of, certainly what I love about the space is there's a lot of evergreen problems to this. But to answer your question around existing sort of solutions, typically you're starting to throw more SSDs, more hard drives out. You have to buy more servers to distribute it. If your problem is really throughput, then you should be going into memory. And MemSQL is really the easiest, fastest way to do that. In terms of any sort of migration, going from PL SQL to MySQL is just an ETL operation. And that's something that's part of the process translating.
Do you want to ask a question
Sure,
before we
yeah.
go to the audience? We have one in the audience waiting, so.
Yep. So you talked more about putting things on the memory. So the read write. How does it? Do you do both read write in the memory?
Absolutely.
Okay. So the entire fastness depends on adding more memory then.
In terms of scaling a quick workload, yes. You're going to want to basically put your data into memory. Coming out of Facebook scaled that way. I mean, most of Facebook's infrastructure is memcached. You have a 93% chance of having the entire experience served out of memcached on Facebook. The other thing that they did was converting PHP to C++. That's called hip hop. So those 2 things actually made it very easy to scale to that many users. Our sort of analogy is you go into memory the proper way with lock-free data structures, and then you translate your SQL into C++.
So are you compatible only with MySQL type databases, or do you also go on top of Hadoop?
No. This is a OLTP solution with a MySQL compatible interface. ODBC, JDBC works out of the box. So any sort of ecosystem tool works with us.
So I mean, before we get to this question, I just want to make sure we make a distinction because Oracle and SAP talk about in-memory. And what you're saying is Oracle really their in-memory is really just caching today.
Well, that product in particular can act as a cache. But effectively, to go into memory properly, you really want to use new theories that have been developed in the last decade or so around how you store that data. You run MySQL in memory, it still thinks it's B trees, and it doesn't apply really in a solid state environment.
Okay. You have a question?
Actually, that leads into my question. So SAP's new HANA in-memory high-performance appliance and the database capability it brings with it, solid-state memory. How does your performance compare with that? And depending on who you believe, if 80% of the world's GDP runs on SAP, and I have nothing to do with SAP, where is your positioning relative to something like HANA running away with it in the enterprise?
So we're a definitive OLTP database, and our focus is in transactionality. A HANA database is more on the OLAP side of things. And in terms of how we offer some of our analytics, you just issue simple SQL statements against us. And there's a finite set that is really, really exceptional. It's just a different sort of product. Just because it runs in memory doesn't necessarily mean that we're in the same sort of business.
But SAP is saying that they'll run all of their applications, including transactions.
There's a convergence. There's a definite need from OLTP side to offer more analytics, and the OLAP side to say, well, we can do some transactions. So it's really just at this juncture for them a focus on what they want to do and what we're focusing on, which is fast data.
Yeah, but as the moderator said, they're looking to make this the centerpiece of their architecture and move all of their solutions onto it. That would include what you're offering.
Pardon me?
That would include competition to what you're offering.
We'll see how that turns out. The fact is we are a best-of-breed product based on the theories that we've implemented, code generation. Nothing is faster.
Thank you.
You mentioned cloud. Do you anticipate that most of your use cases will be on-premise if folks are really looking for heavy-duty, low-latency performance?
I would say yes. I mean, obviously, if you have a huge sort of concern around performance, you're going to want to own your hardware, and it really makes it easy to actually buy the capacious sort of hardware that you need. In terms of the cloud, we love the cloud because that I/O is a shared pooled resource, and that means that that's the first thing that suffers. So we've seen I/O performance being really, really poor in EC2, just because it's virtualized. If you actually elevate your data into memory, primary locus resides there, you've eliminated a bottleneck. The I/O is no longer an issue.
So how do you compare yourself with Fusion IO?
Oh, well, that's a SSD-backed solution. You're using read-write operations to interact with that. We're still substantially faster just on a hardware basis. DRAM sits much higher up on the memory pyramid.
Question down here. Mike's coming.
Two questions. The way I understand is you're going to improve the I/O operations. It's going to be much faster because you are not doing the SQL interpretation. You are doing C++, direct object reference. So if there's a bad SQL, it's still going to be bad SQL. That won't change, right? If the SQL itself has a poor performance, not because of the I/O, either because of the volume of the data or based on whatever else. No, I mean, this is not going to help, or will it?
Well, we apply similar sort of techniques. You can index your data. We can scan 5 million records a second. So the volume itself is partly addressed by being in memory. But if you issue a poor SQL statement, the cardinality about how you join tables is very dependent. It's highly variable how you join. So we do that by hinting. You can actually hint how you want to bind and join tables together.
I just have to interrupt because just to be fair to the other companies, we can come back at the very end and ask questions. My apologies, but I want to be fair to everybody up here. We're over time.
Thank you.
Thank you, guys.
Great. Good job.